All right, good morning. So we are going to solve this NCERT Exemplar problem, rotational motion, focused on conceptual understanding of torque. Before I do this question, I just want to tell you some mistakes in the question. So NCERT has first of all not marked which is the z-axis. There are two axes of rotation in this question. NCERT has not written which one is z dash. For this question, this particular on the right hand side, my right hand side is z. So when you see the book, the axis of rotation on the right hand side is z dash. Again, the other mistake is in the part C, it is not mentioned. The part C is all about comparing the torques created by the force around two axes. Now again, it says z axis and z axis, right? But there are two axes, we know, z and z axis, and therefore for me in part C, this is z dash axis. I just wanted to warn you that NCERT has done some printing mistake due to which it may confuse the student. I am clarifying the assumptions. The axis on the right hand side is z dash axis. In the part C, the first thing that appears is z dash axis. So this is your z dash axis, and later part of the part C talks about z axis. Alright, so good morning. Today we will solve this rotational motion NCERT exemplar problem. Very important problem for you to understand the real meaning of the word torque. It's a very conceptual problem, and therefore I'm doing this. Let's read the question. So we're given two axes and a single force. Single force, two axes. The question is, first find the direction of torque due to the force around first axis, then find the torque due to the same force around the other axis. One hint which is given in the question is that one of the axes is closer to the P, which is the point of application of the force. One of the axes, which is Z dash, okay, so this is your Z dash, and you can see it is closer to the axis. This hint is given to you for part 3. Part 4 of the question says the two torques are calculated and then added. So we have to decide whether we can add them or not. Now let's start discussing this problem from start. First thing, whenever you solve these questions, what do you need? In a torque case, what do you need? You need a position vector and a pivot. Pivot is the point starting from the axis till the point of application of the force. Wherever the force is getting applied, there is a point, and then there is a point on the axis. Start the vector from the pivot point, which is the start point of the axis, till the point of application of the force. And this is exactly what I've done in this diagram. There are two pivot points. This is your pivot point. This is your second pivot point. Now, for the first axis, what I've done is I have drawn this line, which is basically the position vector, right? So this is position vector. I am referring to this line. I started it from the pivot point, took it straight to the point of application of the force. So this is your point of application of force. Right? In the second case also, this is the pivot, and then I draw a position vector from the pivot to the point of application of the force, which is this. So the force is getting applied here at point P. It is given in the question, and I extend the vector, which is a position vector R, and the other I call as R. Because this is starting from the Z axis, I call it R dash. The other one is R, right? So first job done. First, find the pivot point. Second, draw the position vector. Next point, extend the position vectors. The reason for extending the position vector is because to find the torque, okay, to find the torque, the tail of the position vector and the tail of the force vector both have to be like this. Okay, this is the R vector and this is your F vector, right? They should start from the same point. They cannot be like a vector addition scenario. Tail, head, tail head is not allowed. Both tails are meeting, and now you're allowed to find the vector product. So if you do this part, which is identify the pivot point, draw the line from the pivot point to the point of application of the force, this becomes your position vector. Extend it further, you are now in a situation where the force and the position vector are making an angle between them. Most of your job is done if you're able to do this much. All right, so let's focus on the part one. For part one, what we need is R and F vectors, right? So see this figure. What I've done is, for the first step, I have drawn the R. So this is my R dash vector. Okay, so where is my R dash vector? This is my R dash. It starts from the axis, right? It starts from the axis, and then it goes towards the point of application of the force, which is P, right? And now what we're getting is, this is my R dash and this is my F. What do I do now? I need to take vector product, right? So my R dash is in this direction, my F is in this direction, and I will do R cross F, right? Remember, this is all happening like this because my board is in different plane, the lamina is in different plane. So if you look at from the point of view of a lamina which is in XY plane, when I do R cross F, my torque vector goes downward, which is minus K. So the choice number one is indeed correct, right? Sorry, it's Z axis, the choice number B is correct. And similarly, if we do the same thing for the other one, let's see what happens. Okay. So I have now drawn the vector R, which is coming from the Z axis. This is my real Z axis, right? And this was Z dash. Now I know this is the value of R and the value of F is this. So if I redraw this, the value of F, if I see the angle, so this is my R, this is my F, and therefore it is F, this is my R. I will have to take the right hand rule from R to F, and you can see the vector torque vector is coming out of the board. If it's the case of your lamina and the vector is coming outward, therefore the vector is coming in plus K direction. So the torque for the Z axis situation is plus K and not minus K. So if you see, the torque created by is minus K. So this is not correct. I hope this makes sense to you. Okay, now what we do is, let's start the part 3 of this question. Part 3 is very interesting because it will ask you to compare the torques which are produced by the same force but around two different axes. Okay, let's see whether we are able to compare the torques produced. It is known to us that Z dash axis is closer to the point and the Z axis is farther from the point P. With this limited information, we need to solve the problem number C. Point P is closer to the Z dash axis, right? And it is farther from the Z axis. Now, angles are not given, right? So either they should have given these angles, right? So if this is your force and this is your R and this is your force, they should have given this angle, not given. Similarly, if this is your R dash vector and the angle is this, theta dash, not given. Now it is very hard to decide which vector will be smaller because F is same in both the cases. The only thing we know that R dash, okay, R dash is smaller, it is closer, but we really don't know because our focus is R sine theta, the magnitude, right? We have to compare the torque caused about F is greater. That means we are talking about magnitude. How do we? So we don't know the angles. We don't know these angles. Now how do we do this? We will have to solve this problem geometrically. So let's do one thing. Let's actually draw the perpendiculars from the. So I will draw the perpendiculars. Okay. Now I know my line of action of the force is this. Okay. Don't worry about the direction of the force. I'm not reversing it. I'm just extending the line. That's all. Ignore this particular arrow which you see. It is just because of the shape. Okay. Now let's see. If I draw a perpendicular from Z, okay, to This is my perpendicular. Similarly, let me draw a perpendicular from the axis to the line of. I draw this. Now, if you just see geometrically, which of the two is longer? You see that this particular one, which is coming from z dash, the r sine theta, which is your moment arm in the formula of torque is equal to r sine theta multiplied by f. Your r sine theta geometrically for the z dash axis is coming out to be longer. Although the z dash axis is closer to the point of application of the force, which is P. But when we do some geometry of drawing perpendiculars, we find although it is closer, but its perpendicular distance from the application line of application of the force is longer. And therefore, my answer to the part C is definitely, if I treat this as z dash, right? So if this is z dash, the question has some error. It doesn't talk about z dash. I'm assuming it says torque caused by F about z dash axis is greater in magnitude. Yes, it is. If the question is first z dash axis is given, the answer is yes. You can see for yourself the r sine theta, right, which is longer, right? It is r dash sine theta because we are now currently using the perpendicular component of r dash. So some questions, you're not given angle, but still by using intuition and geometry, you can still make out that the perpendicular component geometrically at least is coming out to be longer, right? And just bear in mind, in NCERT there is an error. There is no mention whether this is z dash or this is z. Both have been written as z. I have taken this as z dash. If you take this as z and the other as z dash, the situation changes. But the point is, did you learn that sometimes the angle may not be given? You may have to do some construction to find the value of r sine theta and then decide. Let's go to the choice number D. In the case of choice number D, the question says addition of two torques, right? So one torque on the body is getting applied because that torque is because of the force about the z axis. The other torque is because of the force about the z dash axis. Same body, two axes, one producing tau and the other is producing tau dash. The question says add them together. Not allowed. This is not allowed. You cannot add the torques around two axes together. The only way you can add torques is when there is a single axis. You can have multiple forces. Due to those multiple forces, you can find different torques about that axis. You're allowed to add. But if you have two axes, one force, and you're producing torque separately for one axis and separately around one axis, you're not allowed to add the two vectors. I hope this helps. Thank you very much.